Mars, the red planet, a celestial neighbor that has captivated humanity for millennia. Its rusty hue, a result of iron oxide prevalent on its surface, is easily visible in the night sky, setting it apart from the celestial tapestry. Mars is smaller than Earth, about half our planet's size, and has a much thinner atmosphere. This means less gravity and less air pressure. Mars has some of the most dramatic landscapes in the solar system. Olympus Mons, the highest mountain and volcano in our solar system, dwarfs Mount Everest. Valles Marineris, a system of canyons, stretches for thousands of miles, dwarfing the Grand Canyon. These features hint at a dynamic geological past. Mars experiences extreme temperature swings. During the day, temperatures can reach a comfortable 70 degrees Fahrenheit, or 20 degrees Celsius at the equator. But at night, the thin atmosphere offers little insulation, and temperatures plummet to a frigid minus 200 degrees Fahrenheit, or minus 129 degrees Celsius. The allure of Mars predates modern astronomy. Ancient civilizations were captivated by its reddish glow. The Egyptians called it Horus the Red, associating it with their god of war. The Babylonians named it Nergal, their deity of death and plague. These early observations, though rudimentary, fueled a fascination that has endured for centuries. The invention of the telescope revolutionized our understanding of Mars. Galileo Galilei, the Italian polymath, was the first to observe Mars through this new instrument in 1610. His observations, though limited by the technology of the time, marked a turning point. We were no longer just looking at Mars, we were beginning to study it. Johannes Kepler, a German astronomer, made a crucial contribution to our understanding of Mars's motion. He discovered that planets move in elliptical orbits, not perfect circles as previously thought. This discovery, published in his Laws of Planetary Motion, accurately predicted the movements of Mars, laying the foundation for future exploration. As telescopes improved, astronomers began to discern more detail on the Martian surface. They observed polar ice caps that expanded and contracted with the seasons, hinting at a dynamic world. The Italian astronomer Giovanni Schiaparelli observed channels on the surface, which he called canali. This term, often mistranslated as canals, sparked speculation about the possibility of intelligent life on Mars. The mid-20th century marked the dawn of the space age, and with it, a race to explore Mars. The Soviet Union took the lead, launching the first mission to Mars, Mars 1, in 1962. Although contact was lost en route, it paved the way for future missions. The United States, driven by the Cold War rivalry, ramped up its efforts. In 1964, NASA's Mariner 4 spacecraft made history as the first to fly by Mars successfully. It sent back the first close-up images of the Martian surface, revealing a cratered and barren landscape. This challenged the long-held belief of a lush, Earth-like Mars. The Mariner missions continued, each providing valuable data. Mariner 6 and 7 conducted flybys in 1969, mapping the Martian surface and analyzing the atmosphere. Mariner 9 in 1971 became the first spacecraft to orbit Mars, providing extensive images of the planet's surface, including the first detailed views of Olympus Mons and Valles Marineris. These missions marked a turning point, shifting focus from simply reaching Mars to understanding its geology and history. The Viking missions, launched in 1975, represented a quantum leap in Mars exploration. The missions consisted of two identical spacecraft, Viking 1 and Viking 2, each with an orbiter and a lander. This dual approach allowed for comprehensive study of the planet from both orbit and the surface. The Viking landers touched down on Mars in 1976, marking humanity's first successful soft landings on another planet. They captured panoramic images of the Martian surface, analyzed soil samples, and conducted the first experiments searching for signs of life. While the Viking experiments did not find conclusive evidence of life, they provided a wealth of information about the Martian soil and atmosphere. They detected the presence of water ice in the polar ice caps and measured the composition of the atmosphere, revealing a predominantly carbon dioxide environment. The Viking missions were a resounding success, laying the groundwork for future exploration and sparking even more questions about our celestial neighbor. Section 5. Water on Mars, Signs of an Ancient Past. One of the most compelling questions driving Mars exploration is the search for water. The presence of water is fundamental to life as we know it, and evidence suggests that Mars was once a much wetter planet than it is today. The Mariner 9 mission provided the first tantalizing clues, revealing ancient riverbeds and canyons carved by flowing water. Subsequent missions, including the Mars Global Surveyor and Mars Reconnaissance Orbiter, confirmed the presence of vast deposits of water ice beneath the surface, particularly in the polar regions. The Phoenix lander, which landed near the Martian North Pole in 2008, directly sampled water ice for the first time. The lander's robotic arm dug into the soil, revealing a layer of ice just a few inches below the surface. This discovery fueled optimism about the possibility of finding past or even present life on Mars. Section 6. The Search for Life. A Cosmic Question. The search for life beyond Earth is one of the most profound endeavors in science, and Mars, with its potential for past habitability, has been a prime target. While the Viking missions did not find definitive proof of life, they did detect organic molecules, the building blocks of life, in the Martian soil. The Curiosity rover, which landed in Gale Crater in 2012, made significant strides in the search for life. It discovered evidence of an ancient lake that once existed in the crater, suggesting that conditions may have been suitable for life billions of years ago. The rover also detected methane in the Martian atmosphere, a gas that can be a byproduct of life. While the presence of methane is not conclusive evidence of life, it is a tantalizing clue. Methane can also be produced by geological processes, and further investigation is needed to determine its source. The search for life on Mars is ongoing, and each mission brings us closer to answering this fundamental question. Section 7. Recent Discoveries, Unlocking Martian Secrets. The pace of Mars exploration has accelerated in recent years, with multiple missions providing unprecedented insights into the red planet's history and evolution. The Perseverance rover, which landed in Jezero Crater in 2021, is equipped with advanced instruments to search for signs of ancient life and collect rock samples for eventual return to Earth. One of the most remarkable achievements in recent Mars exploration was the successful flight of the Ingenuity helicopter, a small solar-powered drone that accompanied Perseverance. It marked the first powered, controlled flight on another planet, demonstrating the potential for aerial exploration of other worlds. Data from the InSight lander, which touched down in 2018, has revealed that Mars is more geologically active than previously thought. The lander detected numerous Marsquakes, indicating ongoing volcanic activity beneath the surface. This discovery challenges our understanding of Mars's interior and its evolution over billions of years. Section 8. Future of Exploration, Human Journey and Beyond. The quest to understand Mars is far from over. The next decade and beyond promise even more ambitious missions, including the potential for human exploration and even colonization. NASA, in collaboration with international partners, is developing plans for a human mission to Mars, potentially in the 2030s. This ambitious endeavor will rely on advanced technologies and a deep understanding of the challenges posed by the Martian environment. The prospect of human settlements on Mars, once the realm of science fiction, is now being seriously considered. Establishing a permanent human presence on Mars would be a monumental undertaking, requiring innovative approaches to resource utilization, habitat construction, and long-term sustainability. The exploration of Mars is a testament to human ingenuity and our insatiable thirst for knowledge. As we continue to unveil the secrets of the red planet, we gain a deeper understanding of our place in the cosmos and the potential for life beyond Earth. Thank you for watching. Please subscribe to support our channel. Thank you. Peace and love to all.